This is our second class of the chapter Index Number and Moving Averages. Now, in this class, we are going to discuss the second part of the chapter, that is the moving average. Now, before we go on discussing, let me give you some background of the chapter. Now, for commerce students, this is redundant because you people may have, I'm not saying you have, but you may have completed this in your economics or commerce, I don't know, whichever subject it is. So basically, to start off with, let us talk a little bit about time series. Now, what is a time series? Time series means it is collection of data of anything. It can be of some production, it can be of sell, it can be of the cost of any commodity, it can be anything. So collection of any data over a period of time is called time series. Obviously, the period has to be of equal interval. Say, for example, over every year, over every month, over every week, maybe over every day as well. Now, obviously, it can be a long term time series, it can be a short term time series. Long term, obviously, if you are collecting the data over a longer period of time, say for example over a year, over a decade. And for example, a very good example of long time series is population, your census. Census is obviously collected over 10 years, so definitely it is a good example of a time series which is of longer period. Then it can be of shorter period as well if you are collecting data over days, over months. Say for example, you are keeping track of temperature of a particular area over the months or over the weeks, so that can be a time series of shorter period. Now, whenever you have a time series of for a longer period, then that gives you a trend which is the general trend for that particular parameter or particular thing that which we are on which we are collecting the data, and that is called the secular trend. The secular trend means, say for example, it may so happen that there can be some sort of variations happening in one year or the other, but the secular trend gives us the general trend of that particular item. Say for example, you are selling a product. Now you are collecting the data over years. So whenever you are collecting the data over years, say that item is sold 1,000 units over a year on an average. Now it may so happen that some year there may be more sell, in some year there may be less, and in some year there may be, due to some arbitrary, some involuntary cases, there can be some irregular sell pattern. But the pattern which you get over the long period of time, that gives us the general trend which is called the secular trend. Now, just we talked about variations. Now, what is variation? Variation are the disturbances or the irregularities which comes in the data while we are collecting the data. So there can be different kinds of variation. First one is seasonal variation. Obviously, say for example, you are selling cold drinks, you are selling ice cream. Definitely the sale of the ice cream and cold drinks in the summer months will be more, and in the winter months it will be less. So that gives us the seasonal variation. Cyclic variation means short-term variations. Short-term variation means, say for example, I am collecting the data for over years, but definitely in that, if we just look into the data in months, we will find that in 1 month the sale is higher, in 1 month the sale is lower. So the variation happening in a shorter period of time, that is called a cyclic variation. Then the third one, irregular variation. Now irregular variation means the variation which we are unaware of, or which happens out of nowhere. For example, say if, currently we are facing one, that is, we can understand that for any product, it may be you are selling it or maybe you are producing it, you can understand that the sell or the production, they are both abnormally low than what it should be. It is pretty much not the amount what it should have been otherwise in a normal year, because we are currently going through a pandemic, and the pandemic has definitely forced us into lockdown, and due to that lockdown, the all kind of businesses are definitely, it has come to a standstill. Now slowly it is opening up, but definitely doesn't matter how much it opens up, still this year it is not going to be able to cover up the sell or the production which it could have in a normal year. So this kind of variation is called a irregular variation. Now comes the role of moving average. What moving average does? Moving average helps us cutting down on the cyclic variation, or if we have irregular variation, and helps us finding that secular trend. So moving average is a tool which we use to find the secular trend in the data which we have collected over a period of time. Fine. So now let us understand how we are supposed to calculate moving average. Now before that, we need to understand what are the types. The first type is an n cycle moving average. N cycle means n is any periodicity. It can be 3 cycle, it can be 4 cycle, it can be 5 cycle, depending on how our data is. And cycle means it is the period which we are talking about, that how many, what is the unit of the time which we are dealing with. It can be weeks, months, years, even days as well. And then next we have n cycle centered moving average. So we will be discussing all these through examples. So let us start off with the first one. The first one is a 3 cycle moving average. Now 3 cycle means it can be a 3 yearly moving average, it can be 3 weekly moving average, it can be 3 monthly moving average. So I'm not mentioning yearly, monthly or weekly. So that is why in general I'm mentioning 3 cycle. So depending on the problem, depending on the situation, it will change. So let us take one example, so which will help us understanding it much better. So the question is, calculate the 3 yearly moving average of the following data. Now you are given a data where over 7 different years I have collected the data, and the data values for each and every single year is given. Now I need to calculate the moving average. Let us see how to do this. Now for this we need to draw a table. The table should look something like this. So we are going to make 4 columns. In the first 2 columns we are going to copy down the values which are given in the problem, that is the number of years and the corresponding values. Then we will make 2 more extra column. In one we will be calculating the moving total, and then we will calculate the moving average. Now let us see how to calculate the moving total. Now in moving total is basically sum of corresponding or back-to-back 3 years data. As we are calculating 3 years moving total, so it will be sum of back-to-back 3 years data. So for the first moving total, it will be sum of the first 3 years, and whatever the value comes, I will be writing here in the middle row. Next 3 years, that is this 3, we will be writing here in the middle row. Then again the next 3 we will be writing here. This next 3 I will be writing here in the middle row, and so on till the last 3. So for example, this is the first sum. You can see if we add up the first 3 set of values, then whatever the value comes, I will be writing in the middle position, and that is 11 for the first 3. Then for the next 3 it is 16. Then for the next 3 once again it is 20. For the next 3 it is 25, and for the last 3 it is 31. Fine. So we have found out the moving total. As we can see that there won't be any other moving total available. Why? Because for all the corresponding 3-year sets I have already calculated the moving total. Then I have to find the moving average. So now by the word average we can easily identify what we have to do. What we have to do, as we have added up 3 values, we are going to divide it by 3. So 11 divided by 3 gives you 3.67, 16 divided by 3 gives you 5.33, 20 divided by 3 gives you 6.67, and so on. So you get the moving averages. So this is how the moving averages look like. So your problem is solved. Now, this really doesn't give us the complete picture, or this really doesn't help us understand that what we actually did. To understand it better, we will be plotting a graph. So remember, in the questions there can be an added part where you have to draw the graph of the moving averages. So let us see how to draw the graph. See here. So this is the graph of the moving average. Now the blue line or the violet line that you see, these are the data values at each and every single year. So we have to plot all the data values on each and every single year, and we will be plotting the moving averages at the middle values of the year. So that is, for example, let us go back to the previous slide. So here we are going to plot 3.67 over 4, over the second year, 5.33 over the third year, and so on till 10.33 over the 6th year. So once we have plotted this, you can see the orange line or the saffron line which you see, which is depicting the moving average. You can see that line is more or less straight line, not exactly a straight line, but definitely more or less a straight line, much less perturbed than the values of each and every individual year. So therefore it is easy for us to see that the moving average is giving us the secular trend. Secular trend means that is exactly how the cell or the production or whatever the values here given should be over a period of time. But on individual year, you can see there are heavy fluctuations here and there. So these fluctuations are called the variations. Here, for example, if you can see this here, the cell is very low, or whatever the value is very low. Here the value is very high. So these are the fluctuations. These fluctuations are called the cyclic fluctuations. Right? And the straight line, or the line which is the best fit, which we will study later as the regression line, is called the secular trend. Fine. So moving average help us to get closer to this that regression line. So here we have 7 data value. If we would have had more number of data value, you could have seen that this particular graph would have been much more better, or you could have seen the moving average is giving us much better sense of the trend. Let us move to the next one. Let us take a 5. Now I have it should be a 5 cycle moving average. Now here also I am taking 5 yearly, so I am taking over years. So you are given the time series where from 1986 till 1995, for 10 years, the production of steel in tons given, and then you have to calculate the 5 yearly moving average. So 5 yearly moving average means I will have the same columns, but in this case I will have the sum of corresponding 5 years instead of 3. So the first one is going to be sum of this 5, which comes right here, then it will be the next 5 which comes right here, and so on. And then once we have calculated it, we will be dividing it by 5, right? So we will be dividing it by 5, right, all the way through. So basically, if I just draw the lines, this is how the lines look like. So all the sum over 5 years and then divide them by 5, right? So let us plot this one as well on the graph. So if we plot this one as well, you see the similar kind of a situation here. If we plot all the data values, which is the violet line, it is giving me a graph where there are a lot of variations that we can see, but the moving average line that is represented by the orange line, you can see it is more or less straight. So this shows that over the 10 years the production has increased considerably. Now let us move to the next one, which is the 4-cycle centered moving average. Now 4-cycle moving average can be a normal average as well, but now we are talking about the centered moving average. So let us see how centered moving average works. Before that, let us see what the question is. The question is given: the profit of a soft drink farm in thousands of rupees during each month of the year is given below. Calculate the 4 monthly moving average and plot these and the original data on the graph sheet. So I am going a step further. So I am going to show you the 4 yearly or 4 monthly centered moving average instead of the normal moving average, and I am not plotting it. So if you want, you can just plot it and you can check for yourself that how it is coming. But let us see how the centered moving average works. Now just this graph is a little bit smaller because of the reason, as we are calculating over 4 cycle, you can see if there would have been odd number of cycle, then I could have had a middle value. But as I am calculating it over a even number of cycle, so therefore we don't have exactly one middle value. So therefore, whenever we are trying to find the 4 monthly total, we have to write that 4 monthly total somewhere in between the values. Now as we don't have a middle value, we have to make place somewhere in the middle to write the value. So that is why I have left one gap in between. If this would have been an odd number of cycles, say for 3 monthly or 5 monthly, then I wouldn't have had to keep this space. Understood? So therefore, in each and every single case, the idea will be something like this. So let me just draw the lines. So this is exactly how the lines look like. So you are adding all these values together, and whatever the value comes, you write here somewhere in the middle. So you have to understand where the middle should be. Now similarly, let us go back, let us draw all the lines. So this is how the sum has been taken, adding 4 consecutive data. And then we know how to calculate the moving averages. So definitely divide it by 4. So if you just go on dividing all the moving total by 4, you get your moving averages. Now comes the point where we need to understand how to calculate the centered moving average. Now to calculate the centered moving average, you can see it is pretty easy to see that we are just adding this to value up and dividing it by 2. So we are just taking the average of the consecutive moving averages. So it is like average of the average. So if we take average of all the moving averages taking 2 at a time, then whatever the values we get, these are called the centered moving average. Fine. So let me draw the lines here as well. So this is exactly how the centered moving averages are taken. So again, similarly, if you want to plot the graph, you can plot the graphs by plotting all the profit values for all the 12 months and then plotting the centered moving averages on whichever corresponding month it is. So the first centered moving average will be plotted over March and the last centered moving average will be plotted over October. Fine. So I think the idea is already clear now. So this is exactly what this part of the chapter is like. Simple. So all you need to do is calculate the total and divide it by the number of cycle and plot it if the question asks you to do so. Fine. So thank you. If you have any doubt, as always, do clarify.